Hello, I'm Abdelrahman Osama. I'm doing retinal disease detection using both traditional image processing and deep learning. I developed a desktop GUI where the user can upload images, analyze them, and compare methods. My contribution is building a hybrid system. Task 1 is traditional analysis with feature extraction. Task 2 is deep learning methods using multiple AI model. Task 3 is direct comparison of both methods. This is not just code, but a full interactive medical portal with login, navigation, zoom, and visual options. My AI and new machine vision. My new AI is a multi-model retinal disease detector combining efficient net, RasNet, DenseNet. Instead of relying on only one model, the system show predictions from all three, which improves reliability and reduce bias. My new machine vision is a traditional pipeline that enhances the image, extracts vessels, detects exudates, hemorrhages, and even estimates the fungal infection likelihood. This provides quantitative measures like vessel density, lesion counts, which complement the AI prediction. So let's start. Okay, so here, as we can see, there's six images: clash enhanced blood vessel exudates, hemorrhages, and fungus. And this one is the overlay with vessel density of 2.8, exudates of 446, hemorrhages of 186, and the fungus likelihood is low. As it's also written in the task, let's use a different image. Okay, so this is the original and the six other images. As you can see, there is a lot of fungus compared to the previous one. So here the density is zero point 0.6, exudates is 168, hemorrhages is 1791, fungus is high, fungus likelihood. Let's go to task 2 for the deep learning. Okay, so the original image as well as three curves: F1 score, precision curve, and recall curve. Efficient net is detecting disease risk at DR, while RasNet is detecting disease risk DR as well. DenseNet, on the other hand, is detecting disease risk DR and LS. Uh, let's use the different graphs. Here, it's the predicted finding distribution, disease risk DR, ARMD, MH, and DN, and the agreement heat map. Finally, the confusion matrix and the ROC curve. Efficientnet is 0.96, AOS, RasNet is 0.9697, as well as DenseNet, and the confusion matrix is visible here. Let's use the second image. Okay, so these are the F1 score curve, as well as the precision curve, as well as the recall curve. In task 2, deep learning efficient is detecting disease risk, ARMD, MHTSLN, while RasNet is detecting disease risk, ARMD, and MH. DenseNet, on the other hand, is detecting disease risk, ARMD, MHMYA. And the distribution, this is the fungus distribution visible, as well as the agreement heat map. Uh, let's go to the final one. Okay, so the ROC curve 0.96, DenseNet 0.97, as well as RasNet, as mentioned earlier. And let's go to the final comparison for the first image. As we said, first image, the vessel density is 2.77%, exudates count 446, hemorrhage count 186. The fungus likelihood is low. Both methods provide complementary insights, traditional analysis over detailed feature extraction. And let's also do for the second image. As mentioned earlier, 0.61 vessel density, exudates count is 168, and so on. My limitation and improvement. The research paper we built on mainly focused on deep learning classification. It had three limitations: no traditional feature analysis, reliance on one model, limited visualization. My improvements were: I added traditional feature based analysis, which is image processing. I used three AI models side by side. I implemented visualization options for interpretability and packaging everything into a usable GUI. My own limitations. Of course, my project has its own limitations. The AI models are not fully fine tuned due to limited dataset size and GPU resources. Also, only the retina role is complex. In conclusion, my project contributes a hybrid retinal analysis system that combines AI, traditional vision into one application. It improves interpretability, usability, flexibility compared to the original research paper. Thank you for.
Hello, my name is Zeyad Khairy and my TP number is TP074127. And today I'm going to be talking about my thoughts in the project for MVI. So the project is divided into three parts for each member, which is task 1, task 2, task 3. And for task 1, it's a simple and classical machine learning model. It uses, I've used in it, yeah, it does image processing, and I've used in it SVM. And for task 2, it's a deep learning model. So I've used efficient net v2 CNN model, and I've already loaded and trained everything needed for them. I ran everything and trained what needs to be trained. And third task, which is the GUI, partially it's a group part, and of course the main stuff is individual. So we run it and we see what we have. Yeah, and first there is a login page which every member has it. So yeah, the username is admin and the password is 1234. Then we go inside. We have five members. I'm number two, the diabetic one. So yeah, let's choose just any image. Yeah, here we have the option to select image. We can select any image from the desktop. And here we have prediction options. We have task 1, which is classical ML, SVM, and deep model, which is task 2, CNN. And we have chosen this image uh, right now. And this is the prediction we'll see right now. And we'll just use task 1 to see what we'll get. And we get the probabilities. No DR is 0.3349, DR is 0.665, and the confidence is 66.51%. And here we have the task 1 details and metrics and all that stuff. So these are the metrics for task 1. They are not from the image here, they are from the train model itself, which is this one. Yeah. And the confusion metrics, and they're both of them when doing the thing, they are saved here in this file. Yeah, this is the path. So I don't know, I showed it. Okay, so and then we have the image processing. It depends, it's not saved with them because it depends on the image that you use. So yeah, let's go with the task 2 and we see. Yeah, so it says prediction. Oh yeah, firstly you have the grade cam. So yeah. And then it says prediction deep model DR. So the probability no DR is 0.0143, while the DR is 0.9857. The confidence is 98.57%, and as we can see, the confidence here is way higher than the classical model. So yeah, and here it just says that the grade cam is saved at this path exactly. And yeah, we'll go here. So these are the metrics for task 2. So yeah, these are all the metrics and all the stuff. Here is the loss curve, accuracy curve, F1 curve, confusion matrix, and they're all saved here from training. And we have also the file for grade camp. These are all the models that have already ran. So yeah. And that's it for my part. Uh, Thank you so much.
Hello, my name is Naif Mohamed Hamid, and my TP number is 073471. Today I'm gonna explain my work, which is about the brain MRI edge protection. The first thing, what I did here, task 1 and task 2. I already run it because it will take a long time to run it during the presentation. So if you run the task 1 first, it will open the automatically the GUI for task 1. If you run task 2, it will open the main menu, and from the main menu I will show you everything. This is this is the task 1. It will open the app traditional. This is the GUI, and this is task 2. It will open automatically the GUI. It is the task 2 GUI, and this is the group GUI, and this is my main menu. Okay, I will show you everything. For task 1, I couldn't predict age based on based on feature or something. So based on feature, I can show the mean intensity and the image processing. After running the code for task 1, it is measuring and sorting and calculating everything and putting everything in folders, and you can browse it from here. But before that, I will show you the group. This is the group. You can write admin 1234. I can open my file here. Here you can choose between the traditional method and AI method. I will choose the traditional method. Here you can, after running the code, it will explore here from here the GUI, the photos. You can explore everything. Here is the features. Here is the name of the photos, or you can choose the, this is from the folder. You can choose the also the patients if there's patient or something. Here you can zoom in the photos. Here is the features, the mean, the intensity, the histogram. Here you can search about the photos. Let's go back to the main menu. Now it is, I will explain the AI. AI. Okay, this is the AI. This is the training. It will take time. So I already run that. This is the epoch. It is 60. This is the mean absolute error 4.70, and this is the R square, and this is the accuracy within 5 years. After that, it will save everything into files. It will open automatically then the main menu. But I already run that. Now I will choose the AI method. Here you can explore everything. This is from the Excel file. This is the true age from the Excel file. This is the prediction. You can explore every photo here. This is the error. This is within 5 years. This is, you can change the tolerance. And here you can zoom in. This is the heat map, graph cam heat map, which is not shown in the journal. And which else? This is the heat map, which is the red line where can it predicted. This is the true age, the male, the prediction, and you can search about the photo here as well. And here is the graphs. This is predicted versus true age. This is the mean absolute error, and the R square. You can go down to show the learning curve and along the epoch. And here you can show the distribution of ages. This is all the photo from train photos, which is I will upload the file for that. You can explore every photo here, and this is it. And thank you.
Good morning. I'm Anfaz Mohamed, TP073356, and I did the COVID-19 X-ray classification. So So then I'll be showing you my dataset. This is my dataset. It has two folders, COVID and normal, each which has 162 JPG images, which is 324 images in total. So that's my dataset. And now I will show you the code implemented. So this is our group GUI. This is the group part, this is the login. So I will log in right now. And then I will go into my part, which is COVID. So this is my main menu for my part for COVID, which I have designed. So it has three parts. This is the image processing using traditional method. So what I've done here is I've made a GUI which can, since my dataset is already classified, so there doesn't need to be classified more. So what I've done here is I've made a GUI which can uh, test the image and say whether it's COVID or normal, which is doing diagnosis. So here you can see the confusion matrix, and the accuracy is calculated from the confusion matrix. So here the accuracy is 64.62, which is quite low, and the COVID accuracy is very low, which is 33%. So once we test, we can see that it's very low. So here, also in the confusion matrix, you can see that 22 COVID cases were recognized as normal, which is a bad thing. So, and here also I've done on all of the data, since the lecturer has asked me to show the numbers. So this is the confusion matrix. Now I'll be showing you the demo. So I'll be choosing from normal. At random, I'll choose one. So it is diagnosing as normal. And then I will show you one more at random. This is also diagnosing as a normal. Now going to the COVID dataset, it only has 33% accuracy, so it should not be perfect. So as you can see, now it's showing diagnosing as normal. And maybe I will show you one more as well. It's showing normal as well. Now this is showing as COVID. All right, now I will return to the main menu. So this was using the traditional method. Now I will show you the implementation of AI. I use the CNN. I use CNN method. So I will show you the implementation. So in this one, the accuracy will be improved. So here, as you can see, the false positives and the false negatives have decreased very much. And you can see the accuracy has increased to 96.92, which is very high compared to the 65 or 64 from before. And you can see the confusion matrix, and the accuracy of our COVID accuracy has increased from 33%. So I will run a few tests from normal. And see the result is showing as normal. And one more. And so you can see it's as normal. Now I'll be testing for COVID. You can see that it's diagnosed as COVID. And one more lastly. Also diagnosed as COVID. I'll do one more. Also as COVID. Now I'll return to the main menu. Now I'll show you the third part which I have done, which is an additional step which I've done in order to show the true accuracy. Now the accuracy was 96%. Now with the k-fold validation, can show you the true accuracy. So here what we do is for all the methods, we are using 80-20 split, which will train with 80% of the data and test with the 20%. So what this does is this will train with all of the data, like it will train 5 times with 5 random splits of 80-20. So we are testing and training with all of the data. So here you can see each folds and the confusion matrix and the accuracy for all. And then we can see the average accuracy, which comes to 90%, 90.61, which shows the true accuracy. From previously it was 96%, now it shows as 90%. And the GUI, the tests and diagnosis is runs as the same. I can show you a few examples for normal. It is diagnosing as normal, and normal also diagnosing as normal. And now I can show you for COVID. diagnosing as COVID, and then one more is also diagnosing as COVID. Now I'll return to the main menu. So that's for my part, and then the GUI, my main menu open, and when I press return to menu, it will return to the main login page. And that's it for my part. And I'll show you the main page. Yeah, it has returned to the login page, and that's it for my part. Thank you.